Good morning. Our next presentation is Tips for Growing Vegetables in Your Garden Soil with Terry Lyngso. Terry is a lifelong gardener, a master composter, and a master gardener, a student of the soil food web, and a lover of the natural world. Her garden in Lomamar is a water-wise native garden that she and her husband designed, planted, and maintain. Terry is still active in her 70-year-old business, Lyngso Garden Materials in San Carlos.
Thank you, Cynthia. And welcome everyone to Growing Vegetables in Your Garden Soil. I am going to be sharing with you, talking to you a little bit about what soil is. Soil compaction, which is a problem that an awful lot of people have in their gardens. How to build soil structure and actually what soil structure is. The importance of compost amendments and organic fertilizers. Talk just a little bit about soil, testing your soil, and then a review of the benefits of living soil. So I want to start off right away with this soil matrix that you see on the screen there, and I want to draw your attention to the orange section there. 45% of your soil is minerals. What are minerals? Minerals is the sand, silt, and clay, the parent rock material that's broken down and weathered over time. That is your soil texture. And the percentage of sand, silt, and clay then defines your soil texture, whether it's a sandy loam or a clay loam or a loam. I want to draw your attention to the white part. That is open space. I think most of us don't realize how much open space there is in the soil. And this is space for air and water, so your soil can breathe and water can infiltrate and move into your soil and be held in your soil. Well, how does that get there? See that little green sliver? That's organic matter. And that organic matter is filled with the decomposition of everything that was once alive and the microbial community that does that. And this is who we want to support and grow and develop in our soil so that we can increase the organic matter in our soil, and the soil organisms can do all kinds of things for our plants. So let's talk a little bit about what I have a feeling a lot of you face in your garden, which is compacted soil. So the drawing on the right side shows mineral particles of could be almost as much as 80%. This is a very, very dense soil. This is an example of a soil when you go out and put your shovel into the ground, it won't go anywhere. That's because your soil is compacted. And so this whole talk is really going to be about how to help you to understand how to open that soil up. And some of the things that when you have a compacted soil, it really limits the microbial ability. And compaction is easy to do using a leaf blower or walking across your soil when it's wet. Repeated tilling or turning of your soil, rototilling your soil can all contribute to compaction. Too much fertilizers or and biocides can limit the diversity of the microbial community, and no protection for the soil, no cover, mulch cover or plant cover, that all leads to compaction. And when you have compacted soil, rain and irrigation water runs off. It's very difficult for it to infiltrate. However, when you've got that good biological soil structure and all that open space, water can move in. The microbial community feeds the plant. They have a relationship. Leaves are very beneficial. Leaves are actually nature's form of mulch. When you leave, consider as you're thinking about putting in a vegetable garden and you're changing season, consider leaving the roots in the ground and cutting your plants off at the top. This will provide food to the microorganisms in the soil. Compost is going to apply soluble nutrients as well as life to your soil and organic matter. And mulch, of course, protects your soil. And there's several ways in which you can ensure that your soil stays healthy when you're not growing. And that's a sheet mulch, cover crops, plant cover. It's all something to consider when you're not growing a vegetable crop. So let's talk a little bit about my favorite subject, the soil food web. So it's really these amazing microbes, the bacteria and fungi that create the foundation for a healthy soil. And it's a relationship between the plant and the microbial community. And as we all know, plants have this wonderful ability to take CO2 from the atmosphere and with energy from the sun, break that carbon dioxide down, outgas the oxygen, and then take that carbon and use it to build their bodies. Not only do they do that, they also take that carbon and create food for the microbial community that they leak out of their roots. It's called root exudates. This is very, very important, and this is nature's way of feeding plants. And plants and microbes work together in a symbiotic relationship. And the microbial community is able to mine many of the minerals in that parent rock material and bring that to the plant. It's quite amazing relationship. I'm not going to go into any more detail on this because it's a huge subject, and you will find if you go maybe to the Gardener website and the Lyngso website, you will find podcasts that go into more detail on this. And I really encourage you to inform yourself on this because it's truly life-changing in how you look at the soil. So I wanted you to see an example of what soil structure looks like. So when you have well-structured soil, you've got, as I said, these soil aggregates. So this is a close-up picture of soil from our garden where we pushed the mulch aside and we just picked up a handful of soil. So I think you can see how the soil is kind of bound together, and then you can see all that open space where air and water can move into the soil. And that water can be stored over long periods of time. So in California, in our drought climate, this is really, really important. So if you have good soil structure, then less irrigation is needed, which is really important. And then, organic matter. Sometimes we just need to add some organic matter to our soil. The mineral component of our soil, if we haven't had a lot of plants growing in that area, sometimes has very little organic matter in there. And you really want to have organic matter up around a level of 5% or so, and even more, for your soil to really start performing and working with your plants. So compost is one way to do it. There are many, many different kinds of compost. I really encourage all of you, if you haven't gotten into composting, that's a really fun thing to do. And your own homemade compost can actually be an inoculum that you add to store-bought compost. So compost is going to supply many soluble nutrients and that microbial life. And there's animal manure compost as well as compost made from plant material. The quality really varies. So if you're buying your compost, I really encourage you to just ask a few questions. And if you're buying it in a bag, take a look at the bag, see what's in it. Sometimes labels don't always exactly explain the details. So it's good to know the details a little bit. Then there's carbon. Carbon is really important for the soil. The soil food web needs like we all do, carbon, carbohydrates, nitrogen, protein. We all build our bodies that way, right? Well, so does the microbial community. And the bacteria are 8-to-1 carbon to nitrogen. So they need a lot of nitrogen, they need a lot of carbon. Um, so that's why mulch can be really important for your soil. Also, if you're using an animal manure that has a lot of nutrients in it, sometimes it's good to add a little bit of woody amendment along with it, like a quarter minus fir or something like that. So you're ensuring that your microbes have the carbon as well as the nitrogen and all of the other elements. So I don't know if you were here to see Carol's talk, but she talked a little bit about using the broad fork. And this is a great way to, without rototilling. Rototilling can be very, as you know, if any of you have seen a rototiller go through the soil, it is pretty violent. It's really breaking that soil up. If your soil is really, really compacted, it might make sense to rototill in 2 to 3 inches of a really good compost and maybe something like a quarter minus fur, and do that one time. And then from then on, you're going to make sure that your soil does not get recompacted. But if you've got pretty decent soil and you want to grow vegetables, you really do need to add a little bit of compost a couple times a year. And a broad fork or a pitchfork is a great way to do that, in which you'll take the tines and push the pitchfork or the broad fork into the soil, rock it back and forth. That opens up the soil, creating little passageways. Then spread compost over the top, and then go ahead and do your planting. It's a good idea to do that a couple times a year if you're a full-time vegetable gardener. Another little bit more involved way, if you're considering an area of your garden where you would like to put a vegetable uh, plot in, then if you have some time, sheet mulching is an excellent way to go ahead and help develop that soil. And we've got some great podcasts on that you can see on the Lyngso website and probably on the Master Gardener website. Compost extract is very interesting. If you have a really well-made compost, if you're making your own compost, sometimes you have a good, diverse microbial community in that compost. You can take a 5-gallon bucket, fill it with water, take a paint strainer bag or something like that with holes in it, put about a quart of compost in the bag, submerge that bag in the water and gently agitate it and a little bit for maybe a minute or two, and you'll see the water start to change color. You're getting microbes or leaving that compost going into the water, and you'll also get some soluble nutrients there. And then take that, water it around the root zone of your plants. It's a great way to just add a little bit more diversity of life to your soil. Feeding your soil, remember, you're going to feed your soil, you're not going to feed your plants. You're going to let your plants feed, you're going to let the life in the soil feed your plants. And so organic fertilizers are the best way to do that, because organic fertilizers also have carbon with them. When you use a synthetic fertilizer, you're feeding it's basically a soluble nutrient. It's going into the soil solution. The plant is taking it up directly. It doesn't need any help from the microbial community. And, you really want to include that microbial community, because they can provide a lot. They can actually go out and mine and provide even more nutrients for your plants. I've got a list here of single source. You can buy single source fertilizers, and Carol talked about alfalfa meal as being a good one for tomatoes. Thank you. I just want to point out that blood meal is a very quick source of nitrogen. Feather meal is a much slower source of nitrogen. So sometimes people add both. You'll notice in fertilizer blends that oftentimes there's a number of these individual single source ingredients in a blend, and the blends are made specifically for the type of plant you're growing. And I just want to point out that the three numbers, nitrogen is the first one, phosphorus is the second one, and potassium is the third. Cover crops is a great way to, if you decide you don't want to grow one year, one season, please do put in a cover crop. Don't let your garden plot stay fallow and bare. That is the worst thing you can do. The sun, wind, and rain will compact it over time. So if you can't put a cover crop in, then do cover it with a little bit of compost and mulch until you're ready to grow again. And then in closing, I just want to bring up that sometimes you're just confused and you don't know what to do. A soil test can sometimes be very helpful. That can give you a baseline. It'll let you know what the macro and micronutrient levels are in that sample of soil that you sent off, the soil texture, the level of organic matter, the pH, and then the cation exchange, which is just another way of saying how well does your soil hold on to nutrients over time. So I hope this was helpful. It's a lot of information, and if you care to ask me any questions, I'll be over there. Thank you.